where all the components are like merged together and current flows through. Okay, that's the basic definition of a circuit. And circuits are of two types, that is series circuit and parallel circuit. So first I'll start with the series circuit. So in series circuit, the main thing is that the components are arranged in such a manner that the current remains same through every circuit, through every component and in the circuit. That means suppose this is battery and these two are say lamps. So if 2 amps of current is flowing through the circuit, which means from this battery is a 2 amps of current which is flowing. So the 2 amps of current will flow through this circuit, this component, and 2 amps of current will flow through this component. That means current remains same throughout the circuit and through each and every component. It should be same. Is this clear?
Yes.
And the potential difference should be the sum of. That means suppose this is a potential difference is 20 volts, then suppose it's 12 volts, then this should be 20 minus 12, that is 8 volts. So like if you add the voltage of every component, it should be equals to the total voltage. So that are the two important, you can say, the function or the parameter of a series circuit. Okay. Now you tell me, I've told you the definition. So what's the definition of resistance? What's a resistance?
Um. It's like what opposes the flow of electric current.
Yes, that's very correct. That means that obstruct or that stops or that resists the flow of current, that is known as the resistance. So it's basically a property of material. Property of material, which means the molecules of the material obstructs the flow. They resist the flow. Okay? So that is known as resistance. So if I apply Ohm's law, V equals RI. Okay? Suppose V is the total voltage. Like instead of this 22 or this stuff, if I write V is the total voltage and I is the total current here. This is V1, this is V2. Okay, and this is I and this is also I. Why? Because I remains same in a series circuit. Okay, is this clear?
Yes.
Okay. Now if I apply Ohm's law in this case, then V should be equals to V1 plus V2. Is this point clear?
Yes.
And from Ohm's law, V is equals to Ri. So in place of V, I can write R equals V equals R multiplied by I. In place of V1, I can write R1 multiplied by I. And in V2, I can write R2 multiplied by I. can write RR equals take out R as R1, it's R1 plus R2, and I gets cancelled out. So finally, R equivalent for series circuit is R1 plus R2. Is this clear?
Yes.
Okay, so we write this down. Then we'll move on to the parallel circuit. Draw both the circuits, okay? Draw this circuit, and write all this below it, and also write V cos Ri as Ohm's law, okay? In bracket, write it's
Okay.
Ohm's law.
Wait, so what's the last equation at the bottom?
This one or this one?
Yeah.
This.
Both of them. Wait.
Okay, so actually it's R multiplied by I equals I, and in bracket it's R1 plus R2. Okay?
Okay.
And since I and I are same, so I can cancel out that.
Okay.
By simple mathematics.
Okay, written it down.
Okay. Now solve this question. It's given as there are three components. They all are joined in a series circuit. R1 is given as 2 ohms, R2 is 7, R3 is 21. Find the equivalent resistance.
Is it 30?
Yes, that's correct. It's 30 ohms. Now it's given as the equivalent resistance of a circuit is given as 63. R1 is 21, R2 is 20. Calculate R3 if they all are connected in series.
Mm. $107.
See, the three resistors are connected in a series, R1, R2 and R3. All three are connected in series, okay? And their equivalent resistance is 63. Then you have to calculate R3, that is third resistance which is connected in series, that you have to calculate. Think how you can calculate this.
So is it 41?
It's 22.
Oh.
Because 21 plus 20 plus R3 is equals to 62.
Okay.
Clear?
Yes.
So you can calculate R3. See, R equivalent, which means a resistance which is equal to all these three resistance. Okay? Which means like
Okay.
if you add three resistors of like this resistance, so a one resistor can do that work which all these three are doing. Okay? So that's why it's known as R equivalent or R total sometimes, but actually it's R equivalent, which means that a single resistance is equal to all the resistors. Clear?
Okay.
Okay, now it's parallel circuit. So it's just opposite of the CD circuit, which means, see, this is a parallel circuit. So previously in series circuit it was the current which remains the same, but in parallel circuit it's the voltage that remains the same. So if this is V, this is V, and the total voltage V, which means potential difference should remain the same. So potential difference here is V, it's V, and it's V. Okay. So potential difference across every component and the total potential difference, they all should be equal to each other. That's the very first point for a parallel circuit. Second is the current should be the total of the current through every component. So suppose I1 is the current that is flowing through this circuit or through this component, and I2 is the current flowing through this bulb, and I is the total current. Then I equals I1 plus I2. Okay, is this clear?
Yes.
Okay, now suppose V1 is the potential difference across this bulb, I1 is the potential difference, I1 is the current across this component, and R is the resistance of this bulb, say R1. Same as I2 is current, V is voltage, and R2 is resistance. And V is the total potential difference, I is total current, and R is total resistance. So again, if we apply Ohm's law, V equals Ri. From here, I equals V over R. Can I write it like this?
Yes.
So in place of I can write V over R. In place of I1, I can write V over R1. And in place of I2, I can write V over R2. Okay? Or I can write V over R. Take out V as common. It's 1 over R1 plus 1 over R2. Since V and V are same, I can cancel out. So my final equation is 1 over R equals 1 over R1 plus 1 over R2. So in case of parallel circuit, the total resistance is equals to 1 over RT equals 1 over R1 plus 1 over R2. Okay?
Okay.
So you write this down, and then we'll do your question.
Okay, written it down.
Okay. Now the question is given as there are two resistors that are connected in parallel circuit. One is 10 ohms and second is 20 ohms. You have to calculate total resistance. So I am solving this one. So it's 1 over RT equals 1 over 10 plus 1 over 20. Taking the LCM, you get 3 over 200. Equals 1 over RT. Now since you have to calculate RT, so what you have to do? You just reciprocal it. Or simple multiply RT to both the sides. But it will be difficult. The simplest thing to remember is just reciprocal it. Which means RT will go up here and 1 will go down there. So it's RT. And if you are doing this, then you have to do the same here. So 20 will go up and 3 will go down there. So it's 20 divided by 3. Is this clear?
Yes.
Okay. So you write this down and next question you have to solve. When two resistors 20 ohms and 60 ohms are connected in parallel circuit. So first write this down and then solve it.
Is it 15?
Yes, that's right. Okay. Now three circuits are connected in parallel. 60, 20, 30. Find equivalent circuit. They all are connected in parallel. So I will solve this.
I'm confused. Wait, do you have to do the... You have to put them into the equation?
Yes, which means it's like
Okay.
3 between 1 over 60 plus 1 over 20 plus 1 over 30 that you have to do.
Okay. Is it 10?
Yes, that's right. Okay. R equivalent of a circuit is given as 20. There are two components that are connected in parallel circuit and their equivalent resistance is 20. If R1 is 40, calculate R2. So our equivalent is given here. Okay. Yes.
Minus 20?
See, resistance can never be negative.
Okay.
If they are in parallel circuit, and if it's mentioned, then you have to put the values in the equations for parallel circuit. Okay. Which means that one out. 1 over RT equals 1 over R1. Put R1 and R2 there.
So would it be 1 over 20 equals 1 over 40 plus 1 over R2?
Yes.
Okay. Is it 13.3?
I think we are doing some mistake. See, this is the equation. It's 1 over 20 equals 1 over 40 plus 1 over R2, right?
Yes.
That means if you transpose it right there, so it's 1 over 20 minus 1 over 40 equals 1 over R2. R2, sorry. Now can you calculate R2?
So I times the denominator by 2 to make it 40, and then...
Yes.
Oh, sorry, I did it wrong.
Okay, so do it one more time.
So it's 40?
Yes, that's very correct. So R2 is 40. Okay. Now let me do a quick revision. Okay. So far what we have completed. So I'm starting with the charge. How can you define the charge?
Um, um, It's where you can feel an electric field.
Yes. So the particle around which you can feel electric field, okay? Where you can feel electric field. This is charge. What is current?
The flow of charge per unit time.
Yes, that's right. What do you mean by potential difference?
Potential difference equals work done over charge.
Yes. Okay. What do you mean by Ohm's law?
Ohm's law is potential difference equals resistance times current.
Yes. Okay. What do you mean by ammeter and voltmeter?
Ammeter measures the electric current and voltmeter measures the voltage.
Yes. Now you tell me that electric current, sorry, the ammeter should be connected in series or in parallel?
Series.
Okay. Why it should be connected in series?
Um, um,
See, because in series the current remains the same, right? An ammeter is a device which measures the total current. So if total current remains the same, that means you want it to be connected in series so that there will be
okay.
no deflection in the readings, right?
Okay.
Same as voltmeter should be connected in parallel, because in parallel circuit the potential difference remains the same through every circuit or through every component. And since you are measuring the voltage through voltmeter, you want the same reading, right? You don't want any deflection. That's why it's always connected in parallel. Voltmeter in parallel and ammeter in series. Okay.
Okay.
Okay. Now for ideal ammeter, its resistance, because ammeter also has resistance. Okay. Every component through which electricity flows has resistance. So you want the resistance of ammeter maximum or minimum?
Minimum.
Yes. And why we want minimum?
Um, uh,
So that maximum amount of current flow through, right? Because you are basically reading a ammeter is basically reading a current, right? Suppose there is a weighing machine and it's measuring your weight. So definitely you want it to be accurate. Okay, no deflection. That means same as if there is an ammeter, you want all the current to pass through. Okay, and that's why its own resistance should be minimum so that its resistance should not obstruct the flow of current. This is clear what I'm
okay.
telling, or you want me to clarify it more? Is this clear or not?
Yeah, no, I understand.
Right. Okay, so what do you mean by series and parallel circuit?
Um, Series circuits is where where the current is the same everywhere.
Yes, and there's also second thing for series circuit.
Um,
There are two options, right? There are two parameters. The first, that the current remains same, and second, you can see you have written it, right? So what are the
yeah.
2 points that you have written?
Uh, it travels directly to the component.
The second point is that the potential difference is the sum of the total potential difference, right? V equals V1 plus V2. That were the 2 points. Right? Hello?
No? Yes.
Like, is this clear? Current remains same throughout the circuit, and potential difference is the sum of potential difference through every component. Suppose V1 is the potential difference of first component, V2 is for second, then total potential difference is equals to V1 plus V2. Is this clear?
Okay. Yes.
And how can you calculate R equivalent or R total for series circuit?
It's R1 plus R2.
Yes. And what do you mean by parallel circuit?
Parallel circuit is where the components are separate.
The 2 points that you just wrote down.
Oh, I equals I1 plus I2,
Yes.
and I over RT equals I over R1. Oh, 1 over RT equals 1 over R1 plus 1 over R2.
Yes. So this is the equation to calculate the total resistance in case of parallel circuit. 1 over R2 equals 1 over R1 plus 1 over R2. And the 2 points are that I equals I1 plus I2 and potential difference remains the same through every component. That is V equals V1 equals V2. Right?
Yes.
What do you mean by power?
Um,
How can you define the power?
Energy over time.
Yes. And what's the formula to calculate power in case of electric circuit or electricity?
Uh, um, Power equals potential difference times current.
Yes, that's very right. Okay. Now see this question number first and give me the answer. Can you see the PDF that I am uploading?
Yes.
Okay. You see question number first and give me the answer, like which option is correct.
Okay. Current that is always in the same direction.
Okay. Yeah, that's correct. Now see the question number second. So one by one you solve the questions.
Okay. Um, is it 120 volts?
It's 12 volts, right? I think you're doing some mistake in calculation, like because
No.
it's 12, not 120. So do it one more time. See, it should be 12.
Oh yeah. Sorry. 30 times 0.4.
Yes. So it's 0.4, that means it should be 12.
120. 12.
Yes, 12 volts.
Okay. Uh, should I do the next one?
Yes.
4.8 watts.
4 point, yeah, that's correct. Now see the question number 2. Okay, so it's given as use the circuit symbol to draw circuit since. Okay, leave this question as of now.
Okay.
Okay, now see part B. Okay, so here it's given as describe how the student could use her circuit to investigate how the current through a filament lamp affects its resistance. So you can give me the answer in same manner like in the last lecture I told you how current flows, right, and how the resistance can be affected by flowing current.
Okay.
Okay. You tell me, if larger current will flow, what happens to the resistance?
The resistance decreases.
Yes, that's the inverse relation. That's very correct. So here it's given as describe how the student could use her circuit to investigate how the current through a filament lamp affects its resistance. Which means if here it's given, if you see the components, so it's given as a battery, a variable resistor. A variable resistor is a thing or a component by which you can change the resistance of a given circuit, right?
Okay.
So experiment is actually like this. There's a circuit. Let me draw it. So there's a circuit. Here battery is connected. This 12 volts battery is connected. This is lamp. Ammeter should be connected in series. So here is ammeter. Voltmeter should be in parallel. So voltmeter should be in parallel for this lamp. And here variable resistor. So what happens is if you change the resistance through this or by the help of this variable resistor, the current that is flowing inside the circuit will also change. Suppose at this time the current flowing is 2 amps and resistance is 1 ohms. If you increase this, say it's 3 ohms now, so current will go down and now maybe it's 1 amp. Okay. That means as you keep on changing the resistance with the help of this variable resistor, the current that is flowing inside the circuit is also changing. Since current is changing, so change in current will affect the resistance. Is this clear? So if suppose 1 amp of current is flowing, this lamp has a different resistance. If 2 amp of current is flowing, then this bulb has a different resistance. Is this clear?
Yes.
Okay, so this is the investigation. So how you can describe the current through the filament? So you can describe it like that. The student can use the circuit to the student can use a variable resistor to change the current or to change the flow of current in a given circuit, and because of the change in current in the given circuit, the resistance of the lamp keeps on changing. So she takes a different readings. She takes like 14 to 15 readings and then get the average resistance. This will be the equivalent resistance of the filament lamp or a lamp. Clear?
Okay.
Are you sure it's clear?
Yeah, now I understand.
Okay. Now see this question. Question number C. Part C.
The resistance increases.
Okay, let me read this. Yeah, that's good. Okay, see the next one.
Um, 15 ohms.
15 ohms. I think you need to see it again. Read it. So it's given as use a figure. Resistor filament lamp current of 0.10. So at 10, what you have to do, you have to draw a vertical line.
Okay.
Okay, so 0.10, it's like this. And since this curve is not a complete curve, think how can you calculate something. Suppose, say for example, it's given as calculate the resistance at 0.6 ohms, 6 amps of current. So what you'll do, at 6 amps you draw a vertical line, right? And where it touches your curve, at that point you draw a horizontal line. Okay, that is 10 ohms. So at 0.6 current or 6 amps of current, the resistance is 10 ohms. Is this clear? Right?
Yeah.
But they're asking for 0.1, and at 0.1 if I draw a straight line, unfortunately there is no curve here, right? So for this, what you have to do, you have to extend this curve.
Okay. So you just draw the line.
Yes, so like it's like this and you just have to extend this. Okay, so at you'll get a point somewhere like 6.1 something, right? 6.1 or 6.2, that is your resistance. Okay,
Oh,
and
okay, sorry, I thought it was 1.0.
yes, because it's here, and that's
Okay.
why it's written as estimate the resistance, right? Because curve is not completed here, that's why it's given as estimation, because you're extending this curve according to your sense, right? So that's why it's written
Okay.
as estimation. So this is your answer, like somehow 6.1, 6.2, that's your answer. Is this question clear?
Yes.
Okay, now see this.
Is the first one the filament lamp?
Yes, that's correct.
Um, second one's the last one is the diode.
Yes, that's very correct.
Um, and the second one's the resistor of at constant temperature.
Yes, or it's a graph for Ohm's law as well. Okay, second one. Clear?
Yeah.
Okay, now see this.
Um, Is it 4.5 volts?
Okay, let me check that. So what's your answer?
4.5?
Yes, that's correct.
I'm not quite sure how to do question B.
Okay, so here it's given as calculate the resistance of the resistor labeled R. That means you have to calculate the resistance of this one. Okay, now you know the total potential difference, that is 4.5. Okay,
Yeah.
so first thing is they all are connected. These three resistors that you can see R, 60 and 45, they are connected in series or parallel. Tell me, they are connected in series or parallel?
Series?
Yes, that means current remains the same, and it's given as the ammeter displays a reading of 0.1, which means current here should be 0.1 amps, current through this is 0.1 amps, and current through this is 0.1 amps, right?
Yes.
Now if you use the Ohm's law, so it's V equals RI. So R equals V over I, right?
Yes.
You know the current is 0.1 amps. Only thing is you have to calculate the potential difference. Now the total potential difference is 12 volts. Okay. And
Okay.
we have calculated the potential difference of here as 4.5 volts. Okay.
Oh, so you take. Okay. So is it 7.5?
No, see, the voltage here is 4.5, but it's not necessary that voltage here should be 4.5, because in series V is equals to V1 plus V2, right?
So is it 7.5?
Yeah. So if you do 7.5 divided by point, wait a minute, but this resistance is also there, right?
Okay.
So it should have some potential difference. It should have some potential difference. Is this clear?
Yes.
Okay. So for that, there's a simple. Wait a minute. You'll get confused if I. Let me give you another method. I think it will be simpler. You can calculate through equivalent resistance. Okay. Equivalent
Okay.
resistance, which means I think it will be way much simpler as compared to this code. Leave that. You'll get confused. See, total resistance you can calculate as V equals RI. So potential difference is given as 12 volts. Total current is given as 0.1 amps. So R multiplied by 0.1. So R is equals to ultimately 12 divided by 0.1, which is 120 ohms. Is this clear?
Yes.
So now you have R equivalent, which is 120 ohms, and these three are connected in series. Can you calculate R from here? R equivalent is given and 3
Oh, see.
alternates are given.
Okay. So R is 15.
Yes, that's right. Correct. So this one is much simpler, right?
Yes.
Okay. Now see this one.
The resistance increases.
Okay, so state what happens to the total resistance of a circuit and the current through circuit when switch S is closed. So you seek resistance.
Increases.
See what happened
Um.
when it's switched. It's given as when S is closed. When this is closed, which means now current will not flow through this one. That means it will start behaving like a closed circuit. So what happens is it's only 45 ohm resistance and R remains. Okay, you don't have to consider this 60 ohm. And if you're not considering a 60 ohm resistance, that means resistance decreases, right?
Yes.
And if resistance decreases, that means current increases. Point clear?
Yes.
Okay. Now see this one. Well, I think it's better. Wait a minute. Have you written all these things?
Yes.
Okay. Okay, now solve this one.
Should I draw the circuit?
Okay, leave that just drawing the circuit.
Okay.
We can move on to the next one.
Lamp A.
Okay, so
Because the current is higher at each potential difference.
okay, so you are solving part B, right?
Yeah.
So which is like which will glow brighter?
Lamp A.
Yeah, that's good. And why?
Because the current is higher.
Yes, that's good. Okay, now for C.
The current is lower at each point than lamp A.
Yes. Okay, solve this one.
Oh wait, do I need to use the graph?
Yes. So you just read this question and I'll just, you can see.
Wait, sorry, could you go back to the question?
Yes, yes, yes.
Is the ohmic conductor when the current's the same as the potential difference?
It can be repeated, I don't understand. Sorry?
Is the ohmic conductor when the current is the same as the potential difference?
Not same, they are proportional to each other. Proportional, which means if the potential difference is increasing, so the current will also increase by some unit. That means if voltage is
Okay.
2, current is 4, voltage is 3, current is 6. Like that, they have a constant relationship between them. That means there
Okay.
always be a straight line passing through the origin. Okay, their curve is like a straight line passing through the origin, just like this one.
Okay.
This one, the second one, right?
Okay.
So you have to see where they are behaving as an ohmic conductor. That means through which range, or what's the range where you can see a straight line passing through the region. That's the range for where they behave as an ohmic conductor. See, what's that potential difference range?
1. No.
It's 0 to 2 volts. See,
Oh, okay.
can you see that it's from 0 to 2 volts? They both are behaving like ohmic conductor because they both have a straight line. Almost it's a straight line, right? Then
Yeah.
they take a curve. They took a curve. So they no more behave as a
Yeah.
ohmic conductor. Okay, so the range is from 0 to 2 volts. Is this clear?
Yes.
Okay.
Okay.
Okay, so like this question is bigger because it has some parts. So we'll solve this one in the next class. Okay?
Okay.
Okay then. Thank you.
Thank
Bye.
you. Bye.